Number one, it's an absolute value function, so it's going to look like a B. It's going to have an axis of symmetry. Hopefully by now you realize that this is in vertex form, right? Y equals A times the absolute value of X minus H plus K. Now you can always put these in a calculator and graph it that way. But it's almost easier just to do it manually with the vertex form. All right. Remember, inside any mathematical symbols, we go left to right, opposite the sign, right? So in this case, we're going to go left 2, and outside it's going to be up or down and same sign. So we're going to go up 3. So we start at the middle, left 2, up 3. There's the vertex. It's HK. Vertex is, remember, opposite the sign, so negative 2, 3. Our slope, just the coefficient out here in front, is 1. So up 1 over 1, up 1 over 1. We have an axis of symmetry for absolute value function. It's x equals negative 2. I'm going to have another symmetric here, the other side. That's my graph. Again, you could always plug it into your calculator and get all the information that way. Questions, comments, concerns? Number 3, I have to solve for B. Here I have B on both sides of the equation. So the first thing I'm going to do is get my B's over to one side. I'm going to subtract, oh, I'm sorry, add 3B. I'm going to get this term over here. Add 3B. I have 8B plus 3B equals 7. Now I have to undistribute the B. Take the B out, dividing it. AB divided by B is A. 3B divided by B is 3. I'm going to get B by itself. Now I can divide by the quantity A plus 3. So my B equals 7 divided by the quantity A plus. Number 5, simplify exponents. You cannot have negative exponents in your final answer. Okay. Division. 4 divided by 2 is 2. I have x to the negative 3. Don't forget there's a 1 there if there's nothing there. Division, so I'm subtracting the exponents. So I have x to the negative 4. The larger exponent for x is the denominator, the bottom. So I'm going to put my x in the bottom, change it to a positive 4. Nothing to do with the y to the third. Seven. Here I just have negative exponents to deal with. So I'm going to put this over 1. My 3 stays where it's at. A to the negative 2. Going to put it in the bottom. Make it positive. And the B stays where it's at. Number 9. If I don't have an exponent showing, there's a 1 there, so there's 2 to the first. I have an exponent outside parentheses. So I'm going to distribute the exponents. So I get q to the 1 times negative 1 is negative 1. X to the negative 4 times negative 1 is x to the positive 4. Y to the 3 times negative 1 is y to the negative 3. I have negative exponents to deal with. So 1. I put 2 to the first on the bottom. X to the 4th stays where it's at. And y cubed goes to the bottom. Number 11. See, anything raised to the 1/2, I can also think of it as square rooting, right? I'm going to, now remember, it's outside parentheses, so I have to distribute it to each one of the exponents. Now with numbers, I'm going to take the square root instead of multiplying the exponents. Square root of 49, 7. The square root of 100, 10. Now with the variables, I'm going to multiply by 1/2. So I have a to the 8 times 1/2, or half of 8 is 4. B to the 4 times 1/2, or half of 4 is 2. No negative exponents to deal with? I'm done. Okay, absolute value inequalities. Here, we have to remember that greater thans are going to be or statements. Less thans are going to be and statements. Okay. Make sure you isolate the absolute value first before you determine the or and. Absolute value inequalities, we have 2 cases to consider. We have the case of negative 11, x plus 7, negative 11. Since I multiplied it by negative 1, I have to flip the sign. Or x plus 7 greater than positive 11. So for x, minus 7, minus 7, I get x is less than negative 18, or minus 7, minus 7, x is greater than 4. See the number line. Small number is negative 18. Large number is 4. parentheses because there's no equal sign with my inequality. By the way, OR statements are going to look like parenthesis, bracket, go opposite directions, right? And statements are in between. Bracket or parenthesis, depending on equal sign, and they shade in between. So I have a parentheses, opposite directions. Interval notation. See, I have starts here at negative infinity, always gets a parenthesis, comes in, stops at negative 18, parenthesis, union, starts again at 4, goes to positive. Then solving radical equations, we're going to do this algebraically. Remember, if I get a quadratic, check for extraneous solutions. Actually, you should check all the time. All right, get rid of radical. I'm going to square it. Radical and power 2 cancel out. I get 2m minus 11 equals, I get a binomial times a binomial, m minus 7 times m minus 7. So I have FOIL 2m minus 11 equals m times m squared, outer m times minus 7 minus 7m, inner minus 7 times n minus 7m, and last negative 7 times negative 7, 49. Combine your middle two terms. When you FOIL, 2m minus 11 equals m squared minus 14m plus 49. I have a quadratic. I need to solve for x. So I'm going to get a 0 on my left-hand side. So I'm going to subtract 2m. And I'm going to add 11. Add 11. I get my 0. M squared. Negative 14m minus 2m. 16m. 49 plus 11. 60. I need to factor this. If you use your diamond method, see, positive 60, multiply. My b is negative 16. We add the factors of 60. See, the only way to multiply to a positive, add up to a negative, is a negative times a negative. Two factors of 60 that are going to add up to negative 16, 10 and 6. So I get m minus 10, m minus 6. Set each one of those equal to 0. M minus 6 equals 0. So here m is going to equal 10 and m is going to equal 6. And just when you thought you were done, you must check, because we ended up with, especially when you end up with a quadratic. So I'm going to check m equal 10. See, does the square root of 2 times 10 minus 11, does that equal 10 minus 3? 7, sorry. That's 3. Square root of 2 times 10 is 20, minus 11 is 9, and sure enough, m equal 10 checks. One more. M equal 6. Does the square root of 6 times 2 minus 11, does that equal 6 minus 7? Does the square root of 12 minus 11, which is 1, equal negative 1? Does not. That's an extreme. Doesn't get any funner than that. I don't even see a smile. There you go. So much fun. There we go. Any questions?